we're now going to provide definitions related to the real zeros of a polynomial function. And so remember that a real zero is any real number input that when evaluated, that evaluates to a zero. In other words, if we have a polynomial function p of x equals something, and we plug c into that and it comes out as a zero, then c is a real zero of the polynomial function. The rational zeros theorem is really cool because what it does is it lists all possible real zeros. In other words, we already know that not everything can work, and what the rational zeros theorem does is it says, hey, don't spend your time looking everywhere, just look here. And we'll give a much more formal definition of it here in a minute, but for now the important part is that you know that it lists all of the possible real zeros. Well, up next is the variation of signs, and the idea here is that if we have a polynomial function, the signs in front of the terms changes. And that's the variation of signs. So for instance, f of x equals minus 3x to the fourth minus 3x squared plus 5x minus 2. We go from a negative to a negative to a positive to a negative. And the variation of sign says we have two variances. It changes here and it changes here. So anytime we go from positive to negative or negative to positive, then we have a variation of sign. Notice that we're skipping the x cubed term. All we care about are the actual terms that are found in a given problem. That's all you need to look at. Well, and Descartes' rule of signs builds off of that, and it says based on the variance of signs, we can know how many of each sign the zeros will be. So in other words, this could tell us that we need to look for 3 positive real zeros, or 2 negative real zeros, or any other number, but that's the idea, is that Descartes' rule of signs will tell us how many to look for. An upper bound is a number k such that no real zero of p of x is bigger than k. It says once I know what k is, I don't need to bother checking anything bigger than k because it can't be a zero. Nothing bigger than k is a zero. And the lower bound is the same idea. It's a value k such that no real zero of the polynomial function is lower or smaller than k. So upper bounds and lower bounds also help limit what we're looking at. And all in all, these are the definitions that we're going to be using as we try and find real zeros of complicated polynomial functions.